Welcome to this deep dive. Today we're looking at something you might find in your own cabinet digestive enzyme supplements.
Yeah, they're pretty common.
Totally. And this actually came from a listener who sent in some notes. They'd bought a box and got curious about what exactly is in these things.
Good question to ask, right?
So our mission is to unpack what's inside and maybe more importantly, where these enzymes come from.
Yeah.
It might not be what you expect.
Okay.
Okay, let's unpack this.
Well, people often turn to these, maybe feeling their diet isn't quite cutting it, or sometimes they want a bit of help, maybe recovering digestion-wise after being sick.
Makes sense, like giving your system a little boost.
Exactly, just lending the body a hand to break down food more efficiently.
So this listener, they looked closely at the box, right, and jotted down the main ingredients, stuff like amylase,
For starches, yeah.
protease, which breaks down proteins. And interestingly, it listed two kinds, specified for pH 4.5 and 6.0.
Ah, okay. We can circle back to that pH thing.
Yeah. Then there was lipase, for fats, obviously, and cellulase,
Cellulase, right, for plant fibers. We don't naturally produce much of that one.
and also some ginger rhizome extract was in there too.
Yeah.
Kind of a bonus ingredient.
Common for digestive support, yeah.
Okay, but here's where it gets really interesting, based on these notes about where the enzymes actually originate.
Uh-huh.
So those main ones, amylase, protease, lipase, cellulase, the notes said they weren't from like animal pancreas or something you might guess.
Right, not the traditional source you might think of.
No, the primary source listed, molds, or, well, fungi, to be more precise. Specific types like Aspergillus, Rhizopus,
Oh, yeah, those are big names in biotech.
Aspergillus niger, and Trichoderma rhizi, fungi.
What's fascinating here is, well, it's how incredibly common these specific fungi are. Aspergillus, Rhizopus species, they're workhorses.
Workhorses.
Yeah, I mean, they're widely used in all sorts of industrial processes, not just supplements. Think food production fermentation, like making soy sauce, miso, even some cheeses rely on Aspergillus.
Wow, okay.
And Trichoderma is a major source for cellulase used industrially. So using these microbes, these fungal factories, it's often just way more efficient for producing specific enzymes in large amounts.
Okay, that makes sense from a production standpoint. And getting back to those pH numbers, the listener noted 4.5 and 6.0 for the protease. And they also mentioned enzymes needing certain conditions, sometimes starting around pH 3.0. Why list those specific numbers?
Ah, right. So those numbers, 4.5 and 6.0, they basically tell you the pH level where those specific protease enzymes work best, where they're most active.
Okay.
Our digestive system, it changes pH quite dramatically. It's super acidic in the stomach, maybe down to pH 1.5 or 3.5.
Well, yeah.
But then it gets much more neutral, even slightly alkaline in the small intestine, like pH 7 or 8. So having proteases that are optimized for different points, like 4.5 and 6.0, means they can effectively break down protein as the food moves through these different environments. The 3.0 mentioned probably just refers to the broad range some enzymes can start working in.
Gotcha. So it ensures the job gets done throughout the journey.
Pretty much, yeah, covers more bases.
And the notes also made a good point. While supplements are one way to get these, you can actually get digestive enzymes from certain foods.
Absolutely. Things like fermented foods, sauerkraut, kimchi, yogurt, they contain enzymes from the microbes involved in the fermentation.
Right. And fruits, too. The notes
too.
mentioned pineapple and papaya.
Yeah. Classic examples. Pineapple has bromelain, papaya has papain. Both are types of protease enzymes.
So what does this all mean when you put it together?
Well, I think the main takeaway here, looking at this typical supplement label through the listener's notes, is that those digestive enzymes inside, they often come from pretty specific fungi, Aspergillus, Rhizopus, Trichoderma.
These microorganisms.
Exactly. These microbes that are actually, really common in industry and food science already, not necessarily animal sources.
So it connects to a much bigger picture.
Yeah, if we connect this to the bigger picture, it really shows how much we kind of leverage the biology, the biochemistry of all sorts of organisms, even, humble molds. We use their natural processes for things like supporting our own digestion, but also for making food, for industrial chemistry. It's this hidden world of microbial activity that's, well, everywhere.
That's a really interesting perspective.
And this raises an important question, maybe something for you to think about.
Oh.
How often might these kinds of unexpected sources, like microbes, fungi, be quietly working behind the scenes in other everyday products or processes that you encounter, often completely unnoticed?